Looks like a watermelon.
It's a watermelon.
Now it's one. Now it's a glass.
It's making the Earth.
That is making the galaxy.
It's making us all. Hello, I'm Bashir, and today we're going to take a look at the patterns that we can create using various setups for pendulums. Now we can record the results using sand or paint or even light, and we can get some beautiful patterns from it. So let's take a closer look. Now to start this, we should know that as pendulums get longer, its period, or the amount of time it takes for one complete movement back and forth, also becomes longer. Alright, now we're going to start with a sand pendulum, and the materials we need are fairly simple. Now first of all, I have this big box, which has a bottom to it, and very simply I have this to contain the sand and keep it from going all over the place, but we don't necessarily need it. Now, next we're going to need some sand, obviously. This is common ordinary play sand. It's available at any hardware store. We'll need some string. We need a container to hold the sand. This first bob was made by a friend of mine. It's ceramic. It has a hole in the bottom, right there, and it's supported at 3 points using string. This next one is a soda bottle. I cut the bottom out of it, right there, and the top cap has a hole in it about 1/8 of an inch. We'll screw this on in place. There we go. Now the holder for this is made out of wood. It's a ring that is supported on 4 sides, and the bottle fits very tightly inside of it. This makes it very easy to adjust its height in relation to the table. Now here's an even easier version. The soda bottle is cut off at the bottom. It's got 3 holes in it for support, strings attached to it, and once again we have a hole in the cap for letting the sand out. In this first instance, I simply want to use a single string and attach it up to the ceiling. Alright, now let's take a look at the movement of this pendulum along a single axis. If we were to time it, it takes about 2.5 seconds for it to move along this single axis. Now if we were to move in the opposite direction, it still has a period of about the same amount of time. So it doesn't matter whether it's moving this way or this way, it takes the same amount of time for it to complete one oscillation. But what we're interested in is a combination of these two movements together. So let's give this some energy, either as a circle or an ellipse, and see what we get. At this point I'm speeding up the video, otherwise it would take about 5 minutes for this pattern to be completed. So our result was that we got an ellipse that spiraled inward because the pendulum was constantly losing energy to friction until it stopped in the center. Now when we record the movement of the pendulum, the result is what we call a Lissajous pattern. We could change the shape of the pattern if we could alter the periods along the 2 axes. Now how would it be possible for one pendulum to have 2 separate periods? Well, part of the answer is right here. Our next pendulum is going to look something like this. 2 points of contact at the ceiling coming together to a single strand that comes down to our bob. Now with this setup, the period of this pendulum is going to depend on the direction that it's swinging. If it's swinging in this direction, well then the movement is from the bob all the way up to the ceiling. Notice that the white and the pink string are both moving together. Now if it's swinging in this direction, it's going to have a period of about 2.5 seconds. But if it's swinging in this direction, well then the movement's not going to be the whole length, it's going to be from the bob up to where the strings are connected. So just the container and the white string are moving. If we look up at the pink string, we see in this case it's stationary. Now the period moving in this direction is going to be faster. In fact, let's time it. It's about 2 seconds, simply because from the bob to where those strings are combined is a shorter distance. Do another circle.
What's this?
It's a pretzel.
It's a star.
Yeah, that does look like a pretzel.
It does.
Oh, great. Now I'm hungry. Thanks.
Creating an
So this Lissajous pattern is actually the result of this pendulum having 2 different periods. Now, what would be the result if we ended up changing the lengths of these 2 strings? In this setup, the upper string is much shorter and the lower string is much longer. Now, let's see what it gives us. Once again, we're going to speed up the video, otherwise this pattern would take about 3.5 minutes. In this case, by shortening that pink string at the top, I've made the 2 periods for this pendulum closer to each other. That's very pretty. Now let's change the lengths again. In this case, the strings are tied together about half the entire distance. I've sped up the video about 1.5 times just to move it along a little bit quicker.
Trinity.
It's a bird. It says land inside. Whatever that is. It's a fish.
Yeah, I don't know what that is.
It's a cursive. It's a fish.
Nice job.
Yeah. It's a ribbon. Fish. It's just a fish. It was a fish. It's like a fly wing or something.
I'll move over a little bit.
Now let's try making the upper string even longer. In this trial, the lower string is only about 1/4 the entire length. This video is also about 1.5 times faster.
Let's try it again.
Now with this setup, we got pretty close to a 2-to-1 ratio between the periods, which means the pendulum bob was moving twice as fast in this direction as it was in this direction. And if we look very closely at the picture, it kind of looks like a figure 8. If we match that to the chart, a 2-to-1 ratio, as we can see, gives us a figure 8. So now that we see how we can record Lissajous patterns with sand, in the next episode we're going to see how we can do it with light and also with paint.